There are four common types of forces in physics. These are normal force, friction, tension, and weight. So let's talk about normal force first. Normal force is the contact force. When an object is with contact with another object, then it comes into play. Okay. For instance, this box is kept in certain surface. This surface, uh, when you keep this box in this surface, the force will act in the direction upward. Okay, so this force is denoted by n, and it is a vector quantity, so because it has direction as well. Okay, so it will always be perpendicular to the surface. If surface is like slanted, and you put a box right here, your normal force will be perpendicular to the surface, right? This is the surface, that's why it will always be normal to the surface. That's why the name normal force is. Okay, the second type of force is the frictional force. Frictional force is also a type of force that comes into play when two surfaces are in contact. If there is no contact, there is no frictional force, right? uh, uh, Same like before, let us consider an object on this surface. You are pushing or pulling this object with certain force F in the direction towards the positive x-axis. Then frictional force will always be in the direction opposite to the direction of force applied. In this case, you are applying force in the direction of positive x-axis, right? This is the positive x-axis. So frictional force will oppose this force, which is denoted by small f with arrowhead, because it is also a vector quantity. It has magnitude as well as direction. Third kind of force is the tension force. When you attach a string to this box and you pull it, there is a force that we call tension in this string. Okay, so this is a tension force. This is also a contact type of force. Why? Without contact, there is no tension in this string. If you detach this string from this box or detach from your hand, no tension at all is present in the string. Okay, fourth and last kinds of force is the weight, and it is non-contact force, and we can say this force is a long range force because it acts from the distance. It is because of the gravitational pull. If there is no gravitational pull, weight is zero, right? Simply, W is equal to mg. M is mass of an object and g is acceleration due to gravity. The value of acceleration due to gravity remains constant for the particular planet, but it will be different for different planets, different celestial objects, because it depends on mass and volume as well. Okay, the compactness. So look at here. If z is equal to 0, from this expression w is equal to mass multiplied by 0, you will get 0, right? So if there is a gravity, then there will be weight, and this force is always acting downward towards the surface of the particular planet. If we are talking about the earth, the gravitational force is towards earth, right? If you have an object on the surface of moon, the gravitational pull is towards the moon's surface, not towards the earth's surface, right? So this is uh, the last kind of forces. So in common, in physics we talk about these kinds of forces.